Critical math. We did it. We made it to our piece de resistance, dividing fractions. This is our new stuff that we're going to use all the information from adding and subtracting and multiplying fractions to help us with, but we're going to work on dividing fractions, okay? So when we divide fractions, I think it's the second easiest of the fraction operations. It is a close second behind multiplication, but basically, and that's because we're basically going to divide fractions by multiplying by the inverse of that second fraction. So we're going to use that understanding as multiplication and division as opposites, as inverses, to help us divide our fractions. So we're going to start with some vocabulary. So the mathematical operation that allows for the sharing or blank a number into equal parts is called division. So with division, we are sharing or grouping a number into equal parts. The inverse or opposite of division is multiplication. Okay, and we should know this from elementary that 3 times 4 would be 12, and so then the opposite of that would be 12 divided by 4 is 3. These two operations work hand in hand together. And so if I want to undo something, I can just use the opposite or inverse operation to undo multiplication or division. But in this case, we're going to use the inverse operation and the inverse fraction to, or reciprocal fraction to basically divide fractions. Okay, so here's a new word. It says one of a pair of numbers whose product is 1. It's also known as blank. So this new word that you may not have heard of is reciprocal. The reciprocal of a problem is one of the pair of numbers whose product is 1. That means that if I do 3 times something, I'm going to get 1. I want to know what this something is, and that something is going to be the reciprocal of 3. And reciprocal means flipped upside down or upside down. Okay, so 3 times 1/3 is 1. Now, this is also called the multiplicative inverse. It's just a fancy way of saying that I'm going to multiply by the upside down version of that number. Okay, so when I do the multiplicative inverse, I'm going to flip that number upside down, and that's what we use when dividing fractions. So multiplicative inverse and reciprocals are synonyms. They mean the same thing. And so, like I said, the multiplicative inverse would be me timesing 1/3 and flipping it upside down to get 1, right? 1/3 times 3 over 1 is 1. The reciprocal of 1/3 is 3 over 1. Same thing over here. I'm just going to flip 4/5 upside down, and I'm going to get 5/4, and that's going to end up being 20 over 20, which is the same as 1. Okay, so we just need to remember that that's what we're doing. And the reason we're doing this is because, well, you'll see in a second, but we need to know what a reciprocal is and how to find it, and that we're going to use that inverse operation. All right, here we are. So we've got our standard algorithm here. These are going to be our steps. Okay, first thing we're going to do is just write out our expression. Okay, just write it out. Then we're going to rewrite the expression using our brain tool. And our brain tool is, and you may have heard this before, K, C, F. And that stands for keep, change, flip. So this is the little tool that we're going to use to help us remember what we're doing when we're dividing fractions. So when we divide fractions, we're actually going to keep, change, and flip. And I'll show you what that looks like. After we keep, change, and flip, we just multiply like normal and then simplify if needed. So let's start here. So we've got 3/4 divided by 1/2. Now remember, this means how many halves are there in 3/4? How many of these fit into this? That's what I'm asking. Okay. So first step, write the expression. We did that. Second step, we're going to keep, change, flip. So we're going to keep the first fraction, 3/4. We're going to change the sign to multiplication. And then we're going to flip the second number upside down. We're going to do the reciprocal of the second fraction. So it's become 2/1. That's it. Keep, change, flip. Changing that sign, flipping that second number, keeping the first number. Now we're going to go ahead and do step 3, which is just to multiply across like normal. So we're going to go straight across. 3 times 2 is 6. 4 times 1 is 4. And now we're going to simplify. So I can do this 2 ways. I can reduce first and simplify. 2 goes into both 6 and 4 evenly. And I can get 3/2. And then I can turn it into a mixed number. Or if I wanted to, I could have turned 6/4 into a mixed number first. Okay, and that would have been 1 2/4. And then divided by 2 to simplify. And got 1 1/2. Both ways get me the same answer, but I can go either way. So you can either reduce first, or you can turn it into a mixed number first. Neither are wrong. Okay. So you may be asking me, but Ms. Kirkwood, why are we using the reciprocal when dividing? And it is for the same reason that we know here. So these mean, or is the same. Right? So 6 divided by 3 is the same as 6 times 3/1/3. They mean the same thing. We get the same answer, and that is why we multiply by the reciprocal when dividing. Okay? Remember that this bar is really a division bar, and this dot means multiply. Okay. We're going to do the visual model here really quickly. Basically, what we're going to do is we have 3/4 divided by 1/2. And we're going to show visually what that means. It says the division expression is asking how many halves are in 3/4. And it's impossible to do this without making these fractions have the same size pieces. So the first thing we're going to do is we're going to divide our whole or our chunks into the same size pieces. So we use the denominators here of 4 and 2, and we made arrays of 4 by 2. So that's the first thing we did. So now we have groups of 8 total. Okay. Now we're going to make 3/4 over here and 1/2 over here. So if I divide this back into 4 equal pieces here, so you can see 1, 2, 3, 4, I can color in 3 of the 4th. So that's 1, 2, 3. And I end up having 6/8. And then same over here, if I divide this into 2 equal pieces and I shade one of those 2 pieces, I now have 4 out of 8ths, which is the same as 1/2. Okay, so now what we're going to start doing our grouping. We're going to figure out how many we need. Okay, so I'm going to go ahead and color. I'm going to use my highlighter so it's a little bit even here. I'm going to color the same way it is up there, but without the division. So here's our 6/8, and here's our 4/8. And what we're going to do now is we realize that it takes 4 pieces to make 1/2, or 4/8, right? 1, 2, 3, 4. So 4 pieces, is to make 1/2. So we need to know how many groups of 4 pieces are in 3/4. So here is one group of 4, and that makes one whole group of 4. And then I have 2 little pieces left over. Okay? So we're going to write that one whole group with 2 pieces out of the 4 that we need to make a half, right? So one whole group of 4 and 2 out of 4 left over. That's what we've got. And then we're just going to simplify or reduce. So we've got our 1 and our 2/4, which we're going to divide by the GCF of 2 to get 1 and 1/2. So there are 1.5 groups of 1/2 in 3/4. And if we do this with our algorithm, you'll see we've got 3. Oh, sorry, I was multiplying. Forgot to keep change, flip. 3/4 times 2/1 is 6/4, and 6/4 is the same as 1.5. Okay, so this is kind of visualizing what it means. You're not going to need to do this model. It just helps you understand what we're doing. We can just stick with the standard algorithm. It is easier and faster. Okay, so here we have some practice problems. So our first practice problem is just to find the reciprocal of each fraction. So remember, the reciprocal is the upside down version. So the reciprocal of 2/5 is 5/2. Okay, find the reciprocal of the rest of them. Reciprocal of 1/9, 9/1. Reciprocal of 10/3, 3/10. You're just flipping them upside down. Okay, now we're going to do our division. So remember, we're going to keep, change, flip. Keep, change, flip to reciprocal. Now we have 12/15. Divide by 3, and you get 4/5. Okay, go ahead and pause that video and try 5 and 6 on your own. All right, so if you have finished your problems, you would get 3/8 here for number 5 and 1 1/4 for number 6 by keep, change, flip. Okay, so the next thing we're going to look at really quick are some word problems, because why are we ever going to divide fractions? Well, in real life, we divide fractions for a lot of different things. So let's look at some real life problems that might happen. All right, Allison has 1/2 cup of yogurt for making fruit parfaits. Each parfait requires 1/8 of a cup of yogurt. How many parfaits can she make? So I need to take my 1/2 of a cup and divide it into 1/8 servings to figure out how many cups I can use or make. Basically, how many yogurt parfaits can I make? Okay, so we're going to keep, change, flip. 8 divided by 2 is 4. So Allison can make 4 yogurt parfaits. And that's it. That's pretty simple. You just have to understand what's going on in the problem. So remember, word problems are like stories. What's happening in the story? How am I setting this up? Okay. Number 9, a team of runners is needed to run a 1/4 mile relay race. If each runner, so a team of runners is needed to run a 1/4 mile relay race. So this is the total miles of relays, right? If each runner is running a 1/16 of a mile, how many runners are they going to need? So they have a 1/4 of a mile to go. Each runner can only run a 1/16 of a mile, and we need to know how many total runners will they need. So we're going to do 1/4 divided by 1/16. Keep, change, flip. 16/4, and guess what? That ends up being 4 again. They're going to need 4 runners for this relay. And that's it, guys. That is dividing fractions. So join us again next time to look at dividing mixed number fractions. And I'll catch you again later.